Hello everyone. Today we will be writing an equation of a polynomial function given the zeros, roots, and a point. So let's define first what are zeros and what are roots. So I have here some vocab. First, roots or zeros, which is also otherwise called the x-intercepts of a polynomial, are the values that will make the polynomial equal to 0 by using the zero product property. So let's have an example to better picture what this is. So first we have the g of x is equals to parentheses x plus 3 parentheses x minus 5. What are the roots or the zeros of the polynomial? So all we need to do is to use the zero product property. So that would be x plus 3 equals 0 minus 3 and minus 3. So the first 0 is x equals negative 3. And then the other 0 would still be the same. So it's going to be x minus 5 equals 0. So plus 5 and plus 5 is x is equal to 5. So these are what we call as the, these are the roots. These are the zeros. And these are the x-intercepts. So these three words right here, roots, zeros, x-intercepts, are just the same. We can again determine these values by using the zero product property. On this side right here, we have the steps in writing an equation of a polynomial function given the zeros, roots, and a point. So to better understand these steps here, we're going to go over an example. So let's take this example right here. So I will put the steps on the side so we go over it. Okay. So the problem is write the equation of a polynomial p of x such that p of x has a degree 4 and has roots. Again, I underline the roots. This can be, in other words, this can be, in some problems, they're going to say this as zeros, or they're going to say this as the x-intercepts. So, but then again, the steps would still be the same. So if in a problem, it's using root, we use the same step. If it's using the word zeros, you use the same step. If it's using the word x-intercept, we still use the same step. So let's take step 1. So I'm just going to label S1 right here. So the first step is to determine the roots m, n, and o and plug it into the equation. So let's collect all the roots first. So the first root is x equals negative 3, x equals negative 2, x equals 0, and x equals 1. So these are the roots. And again, we got this from the problem. And then we plug this in. So this will be our m, n, o, and p. And we plug it into this equation. So we're going to be using, instead of p of x, we're just going to use y. So y is equal to a. And then we got a x. Okay, now this time around, what we write here is we do the zero product property backwards. So this should have been x plus 3. So that if we use the zero product property, the x was negative 2. Or the easiest way is to switch the sign. But then again, we are using the zero product property to get this. So we're doing the work backwards. So this one would be x plus 2. So that if I make this equal to 0, it's going to come out x equals negative 2. And this is x plus 0. You don't need to write the 0. And this is x minus 1. Okay, so we've set up the equation. So that's the first step. The second step is to plug in the point. So the point that we have here is, so it says in the problem, it passes through the point negative 1 and negative 3. So this will be our x and this will be our y. So we're now moving on to step 2. So for step 2, we use the same equation, but again, we're filling those in. So, and then we are solving for a. So this would be negative 3 is the y equals a. Our x is negative 1 plus 3. X is negative 1 plus 2. X is negative 1 plus 0. negative 1 minus 1. So again, I've plugged in these two to this to the y and all of these to all the x's. So then we got a negative 3 equals a times positive 2 and then positive 1 and then negative 1 and negative 2. So then I multiply that. So negative 3 equals a times positive 4. And so divide both sides by 4 to solve for a. Divide this by 4. So then our a is equal to negative 3 over 4. So this is our a, and that is for step 2. Step 3 is to write the final equation. So I'm going to write step 3 right here. So the final equation that we have would be y equals negative 3 over 4 parentheses x plus 3 and then x plus 2 x plus 0, I don't need to write plus 0, and x minus 1. And this is the equation for this problem, given those zeros and point. If you find this video helpful, please like and subscribe for more math videos. See ya!